geometric series that go on infinitely. And they just keep coming. And they just keep going. And they keep showing up. And there's more of them. And more of them.
You did the same thing you did on.
And more of them. And look, there's more. And more. And more that way. And more this way. You get a series. And you get a series. And you get a series. And everyone gets a series. And it's all fun and games till you lose an eye with a series.
Why? Murphy, you're just making a mess.
You get my play on words here?
Okay, I see about 5.5.
Alright. Sum of an infinite geometric series. So yes, you can have the sum of an infinite geometric series, which seems weird.
You don't combine the one.
So what's happening here is that if you want to find the sum, it's basically earlier we said that you couldn't, there was no infinity button. Well, there is no infinity button. But depending upon the style of problem there is, depending upon it being geometric with a specific rate, if it has a specific rate, whereas in this case, if the rate is less than, if the absolute value of the rate is less than 1, then we can have a sum of an infinite series, infinite geometric series. Okay. If it is greater than 1, it won't work. Okay? So you get this formula. And there's no, it's just S. That stands for the sum of an infinite geometric series. There's no S sub n's or anything like that. That's how you're able to distinguish this formula from the rest of them. And all you're doing is taking your first term and divide it by 1 minus r. And the rule is the absolute value of r has to be less than 1, which basically means you wind up dividing by a decimal, which makes the value larger. Okay. Now, what's going on here is basically that the value itself, if you look at a graph of one of these types of geometric series, it's approaching a limit. It's approaching a specific value, it's approaching almost like an asymptote, if you like. What's that? Yeah. So you're able to sum things up at that value because you know what it's approximately getting towards. That's why you're able to do stuff like this. Okay. So we use this relatively easy. I don't think I'll be talking for more than 10 minutes, to be honest with you. I'm sure you're very, very upset with that. Oh, Murphy, I just need more notes. That's the only rule you got to worry about. Okay. Because if it equals 1, can you divide by 0? Oh, black hole of the abyss. I think that's a song. Oh, Season in the Abyss. That's a song. It's a song by Slayer. It's a good song. So, here's what we have. We're going to distinguish what first term is, what your rate is, and stuff by looking at it in summation notation. It's a matter of remembering how it looks. Remember, that y equals a times b to the x, where a was like a constant, b was your rate. It's the same basic principle with these, where that thing in the parentheses is always going to be your rate. So think of this as first term r to the n minus 1. Oh, look at that. It's the same thing as an exponential function. Look at that. Ooh, fancy. That's a new voice for me. That's a new one.
Sounds like Ben Stiller.
Yeah, really? Yeah.
How's that sound Ben Stiller?
I don't know, just like when he does
It does.
I was talking this one. I got nothing. I'm sorry. So what's your first term? What's your rate? So all you have to do is this. The sum of the series is going to be 1. I forgot what it was. Oh, sorry. First term. 1 minus your rate. math, sorry. That was really difficult, wasn't it? What's wrong? That's your fault. Easy. All right. Let's sum this one. What's your first term? What's your rate? What? Yeah. First term is 1. Rate, -1/4. Formula. First term, 1 minus the rate, 1 over 1 minus a -1/4, otherwise known as. So you get 1 divided by 5/4, which is 4/5. What was that one? First one was what? 3. What's show this one? It's easier with this one. No, it's not showing. Never mind.
Wait, can you get that first? Wait, the other one.
All right. Pardon me. Too easy. Too easy. Oh no. What is the rate? I have an answer and a first term. I need to find my rate. Oh, a sum, a first term, and a rate. Oh no. I am afraid. What? Try to give you guys a little bit of humor, a little bit of zest. Fill in the blanks. So, do you guys remember the rules of ratios? That's all this is. Fraction equal fraction. When you have a bunch of junk on the denominator and you have an answer on the other side, yeah, don't even have to do that. Do an exchange-o-change-o. The exchange-o-change-o means I'm just going to flip-flop these two and say 1 minus r is 4/10. What's wrong with that? 4/10 is 2/5. Move the r, move 2/5. You get 1 minus 2/5 is your rate, otherwise known as 3/5. We did exchange-o-change-o last year in geometry when you had trig functions. We did that in here too. Whenever your unknown is in the denominator and you have the trig of a number, just exchange-o-change-o with it. Yes, ma'am?
But they tell you like if that like kind of gives you some like if it's infinite or like
They'll say the sum of an infants or you say it's block. They have to. Otherwise you're like, I don't know, I just one, I don't know. You kind of have to have a little bit more verbiage in there. I just moved it around because you're in that section. Or I could say find the different value and make you guess which one's right. Do you need more information than that? That's all I got. I probably could have done this yesterday at the same time, but I didn't because I am, if not nothing more than a person that likes to make sure that you guys have an easier weekend sometimes. So let's see which one would you like.
Do you want us to add it to the?
Yeah.
Yeah.
Maybe got a quarter. Something to flip a coin. All right, think of number 1 through 10, even or odd.
Even, odd.
There was 6, so that's even. So we'll do evens. Let's do 1836 evens. 1836 evens. What's that?
I swear I had it.
So that's about.
You and so.
1836 evens. Whatever page this is.
I'm not sure.
678.
No, I didn't.
Susan.
Do you want to just have mine? Here, you can just have mine.
Where did you put it that I didn't even notice it? Or
I
did
didn't I didn't touch your stuff. Why would I take your stuff? I have a Chromebook. I have a laptop.
Can I go grab mine then?
No, you can have mine. That's very kind of you, sir.
Again, if not anything but a giver.
You don't want it, Maddie. You're taking it.
Yeah, if you must. You might not find it though.
Where did you put it?
I didn't do anything with it.
Well, then how do you know I might not find it?
I'm just saying, somebody in this room might have been
In
mean.
case, that way I can keep my calculator. What? I just keep my calculator.